Bright Tuty. Every student matters.
Hello everyone, my name is Anima De and today we are going to continue with the chapter of matter in our surroundings with the topic states of matter. So in the previous topic we had learned about the different characteristics of matter. We had seen that how matter, what are its physical nature of the matter. That matter, matter is made up of small particles, it is having space between them, the particles have interparticular attraction between them and they are continuously in motion. Now we are going to carry on forward with the topic further into the states of matter. We are going to see that how these characteristics of particles of matter influences the different states of matter. So today's topic would be the states of matter. Now if I ask you what are the different states of matter, I know you already know about it, that it is solid, we have liquid, and then we have gases. So these are the prime states of matter, though you would see that there are other states of matter as well, which we will learn in later classes. Now solid, liquid and gases, when we have to define about their characteristics, their properties, we say that solid has got definite shape. They have definite shape, they have definite volume, and solid also have definite mass. This is our explanation regarding solid. When it comes to liquid, liquid has got no definite shape. That means it takes the shape of the container. Fine. So in case of liquid, you would see that it does not have any shape. If you take it in a cylindrical glass, then it will take the shape of the cylinder. If you take it on a flat disc or a flat plate, then it will take the shape of the flat plate. So it takes the shape of the container in which it is poured. But definitely liquid also has definite volume, and yes, liquids also have definite mass. So in this you see that liquids they take the shape of the container, they have got definite volume, whereas they also have definite mass. Whereas in case of gases do not have definite shape. No volume, okay, they do not have any shape, they also take the shape of the container in which it is. They do not have any fixed volume, or rather instead of saying no, we will say that they have no fixed volume and they have mass. So when we look into solid, liquid and gases, solid has got definite shape, solid also has definite volume, and solid has definite mass. In case of liquid, it takes the shape of the container. Whereas when we talk about the volume, yes, liquid has definite volume. And when regarding the mass, then liquids also has definite mass. But gas as a state of matter, we find it takes the shape of the container. It does not even have a fixed volume. Whereas, yes, it has got fixed mass. So these are the basic characteristics of gas that we know till so far. The different states of matter, solid, liquid and gases. And these till so far in what your knowledge has been about solid, liquid and gases. Now let's learn further about it. Now in case of solid, when we talk about solid, we see that, as I told you, it does not have, it has definite volume, it has got a definite mass, and it also has a fixed shape. And you know why is it? The reason is that if we make a comparison with the characteristics of particles of matter, then the particles of solids are very close to one another. Okay, the particles of solid are very close. So if I represent each of these circles with the particles of matter, then the particles of solid are very, very close. So we see the first characteristic, that solid is made up of particles. Yes, solid is made up of particles. Second, the space availability in solid. In case of solid, the availability of space is negligible. It's very, very less. So the space available, space is less between the particles. Fine. Now because the space available is less, that's why we find that the motion that is executed by these particles are restricted. As they do not have space to move, then how are they going to move? So they are unable to move, and that's why the motion, that is the continuous motion, is restricted. Okay, they do not move. The third is their interparticle forces of attraction is the strongest. Very high particle forces of attraction. Okay, so the forces of attraction between the particles is very, very high. And because of these reasons, the solid gets its definite shape, it gets definite volume, and it also gets the definite mass. Now what happens because of this, you would see, because the characteristics of particles of matter of solid is behaving in this manner, that's why the other adjoining characteristics such as the compressibility, fluidity, the rate of diffusion, that also gets affected. Now, for instance, if I just take any solid, maybe a piece of iron, and I exert pressure to it, that means I'm trying to compress it. I'm exerting pressure to it, that means I'm applying force on that particular piece of iron. So I have solid, and that solid is being exerted with certain pressure. Now what will happen to it? You would find that the shape would get distorted. But will it get compressed? No. The particle cannot come more closer to one another. Compression means they are coming closer to one another. Here the compression will not happen. The shape will get distorted. But the particles cannot come more closer to one another because the particles are already very close to one another. Fine. So in case of solid, the compressibility is very, very less. So low compressibility. This is one characteristic we find in case of solid. Next, fluidity. Do you think solids can flow? No, they cannot flow because the particle do not have that space to move. And we know that the fluidity comes only when the particle can move from one place to another. Now, as because their space is restricted, they are unable to move from one place to another. And due to which we find that the solids do not flow. The solids do not flow. So this is another important characteristic about solid. So now if I just take a pen and I drop it down on the ground, what will happen? At most it will break, or there will be no change. It will still remain as a whole. Or if I take the duster and throw it, I just drop it on the ground, what will happen on the floor? Then you will find that the duster would still remain the same. That means the shape of the solid is rigid. Why is it rigid? Because the particles are very close to one another and they do not give any chance for the particle to move away from one another. And the intermolecular forces that is present in the solid is very, very high. So all these three characteristics holds the particles so closely knit that it gives a rigidity to the shape of the solid. That even after application of some pressure, you do not find any change in the shape of the solid in normal conditions. Fine. So we had seen that solids have got definite shape, it has got definite volume, it has got definite mass, it is very low in compressibility, solids do not flow, solids are rigid. Fine. So these are some of the properties that we see in case of solid. Now, if we have to explain the properties of solid, let us take some example. For instance, if I take rubber band, maybe salt, sugar, and maybe sponge. So these are some of the solids that we are taking. Now, each of these solids are very different from one another. In case of rubber band, what happens that if I exert pressure to it, I take the rubber band and I stretch it, then what do you find that it stretches to quite an extent. So the rubber band, if this is the original size, then if I exert pressure, then we find that it elongates, it changes its shape and size. Whereas in case of solid, what happens, in case of salt and sugar, what happens that if I take salt and sugar and just hold it in my hand, then the shape does not change at all. Or if I take it in a container, then we find that the crystals of the sugar or the salt does not change at all. Whereas in case of sponge, so if this is salt, if these are sugar crystals, then we find that they do not change their shape and size when we are holding them in the hand. Next, if I take sponge, then we know that sponge is quite soft. The reason is because it has got air gaps in between them. So the moment we compress it, so if this is the original size of the sponge, then we would find that there are innumerable air gaps between them. So the moment pressure is exerted on them, then it gets squeezed, but the moment we release it, then what happens? The air gaps gets filled up with air again and it comes back to the original shape. So in all of these conditions, we see in case of rubber band, when the pressure is released, that means when we remove the external force, then we find that it comes back to the original shape and size. Again, in case of sugar and salt, even if we place it in a different container or take it on our palm, then also we find that there is no change of shape. Similarly, in case of sponge, when we compress it, when we exert pressure, then the air which is filled in the air gaps inside the sponge gets released and thus the sponge squeezes. But the moment we release the pressure, what we find that the air gaps gets filled up with air and the sponge comes back to its original shape. So more or less we see that solids have got definite shape. And why is it? Because the space available between the particles are very, very less. It's restricted. And as it is less, the particles are unable to move. So the random motion hardly happens there. And as they are very close to one another, the forces of attraction between the particles are very strong. And thus, it gives these characteristics to solid.